Assalamualaikum and very good evening. My name is Muhammad Disazami Muhammad Hafiz and I'm from Group 7 and my metric number is CE 210 and 135. So today I would like to present about simulation 1 or project 1 for Swiss space power system. So there are two simulation, one which out power capacitor and the other one is with power capacitor. Okay, Assalamualaikum and a very good evening to all my fellow friends and doctor. So this is our first simulation for the project one. So project one is by using a generator 6.6 kilovolt star connection and using one transformer and second transformer. So this we call step up transformer and step down transformer. So okay, the information given in the question is by using 6.6 kilovolt for the generator, and then for the frequency 50 hertz, and then from the question itself 1 milli and 1 milli ohm, and second is 4 millihenry. So this for the generator itself. So if we can see that this is the impedance, equivalent impedance given in the question. So the same in here. This is the impedance given in equivalent impedance given in the question. 25k ohm, 45 millihenry. So what we got here is the real power, reactive power. So total up will be the apparent power. So this is the VRMS value, VRMS, and this is the IRMS value. So this is the power factor. So therefore the first transformer, okay, also the first transformer, second load is the real power, reactive power. So total will be the apparent power, P and Q. So next, V RMS and I RMS value. So will be the power factor. Is the power factor for the power factor for the load 3, P for the real power, Q for the reactive power. Total will be the S apparent power. So next is V RMS value and I RMS value. So this is our second transformer. So for the step down itself, this is our real power, this is our reactive power P and Q. So will be the apparent power total. So this is VRMS, this is IRMS value. So will be this is the for the power factor for this section. So what we can conclude for the first simulation is that before adding the power capacitor, the power factor is not the great enough. It's not near to 1. So we need to improving the power factor to make sure that the losses in this transmission line will be reduced. So what we do is that we add the power capacitor. So next I will show the simulation by adding this power capacitor. So by adding the power capacitor itself, the value for the power factor will be increased. So when we want to increase the power factor itself, all the value that using the formula that using to find the power factor will be increased, such as voltage will be increased, current will be increased, real power will be increased, and reactive power will be increased. So for the first thing, for the first transformer will be increased too. This power factor is increasing, improving, so on, which the second power factor also increase, also improving. So the value that to get the power factor also increasing, improving. So same as this power factor also improving. Also when it comes to the last power factor for the last transformer that asked from the question is to increase to improving the bus 4 power factor. So from the question itself it has to improve to 0.9. So when we round off this we get 0.9. So this is what we get from the simulation to make sure that they're near the power factor to 1 the total loss in the our transmission will be reduced. So we want, so what you can conclude from this second simulation by adding the power capacitor is that by adding the power capacitor, it will improving the power factor itself, and then will be improve all the value from from voltage, current, real power, reactive power, and apparent power. So will be improve the power factor itself. So what we want is to improve the power factor as near as to get one. So when we get one power factor, that is the best networking for what we get. So it will will make sure the losses in the transmission will be minimized. So that's all I can conclude from our two simulation itself. Thank you so much, and assalamualaikum.